Alright, for the last video in this particular playlist, we need to deploy our model as an inference pipeline. This is really the capability that I've been waiting for to make this playlist for the new Azure ML Studio. They've had this capability for a long time. It's not new, but they've finally made it as easy as it is to do in the classic version of Azure ML Studio. And so it's going to be a lot easier and familiar for those that have worked in the classic version before. So we have our model here. Even though everything's completed, I often find it useful to do one more submit, one more run. So I'm going to go ahead and run this one more time. It should be fairly quick because it can pull everything from cache. I'll pull up the run details here while we go. So an inference pipeline is the difference between machine learning and data analytics. Really, the idea with machine learning is that we want to take new data in by pulling our data from a database. Now I know right here we just use a CSV file to keep things simple, but we can use a database and not have to use a CSV file. But the idea is that we should be able to run this on a schedule so it gets retrained by pulling in new data, automatically taking it through all the same data cleaning steps, retuning model hyperparameters, retraining the model, rescoring the model, and then using that new trained model and deploying it as a web service so that we have mobile apps, web apps, whatever type of app we want that can call this web service, send it data, get a prediction back, and use it to help people make better decisions, whether it's trying to get our customers to choose products, to buy more products from us versus our competitors. In healthcare, it could be helping us more correctly diagnose something. In this case, it's simply helping us to predict exactly how much new customers are going to cost us in insurance charges. So we have our completed run here. The next step is that we need to make a few changes. So I'm going to, let's see, go back to run overview. All completed here. It took me back here. I actually want, come on, don't do that. Go back here, and I'm not getting my option. There we go. Back to designer. That's what I meant. All right. So once everything's been completed, this option will show up. And you'll notice that if there's anything that hasn't been completed, you won't see this. You'll just see the submit button and the publish button. But we have this one. That means we're able to create either a real-time or batch inference pipeline. Real-time means we only have one or a small number of cases that we want to predict for. And remember, a case is simply a row in this insurance data set. And it would be a row representing a new customer that we don't know yet how much their insurance charges will be. We just have all of their features. We have children, BMI, region, smoker status, and age. So let's create the inference pipeline. And if you're used to the classic version, you might remember this as creating a predictive experiment. Whereas that last one was the training experiment, this was called the predictive one. And in the new Azure ML Studio, we call this the inference pipeline. So it adds these pills here, web service inputs and outputs, giving us an idea of when this web service is called, the data that is sent to it will come in through here, go through all the same processing, and what will be sent back out will be the scored label after going through score model. Now it also added some stuff over here because I had some other pills in the model which I no longer need. In particular, I don't need permutation feature importance anymore because I've chosen which variables I want to keep. So I'm going to drop that one out of here. Similarly, I don't need evaluate model anymore because I've already chosen the algorithm and the features that I want to keep. So I don't need that anymore. What it has done is it took that tune model hyperparameters, the split data, and combined it here into a registered model. So what is a model? It's the set of training weights to predict or make a score model out of the features. So if we had used a linear regression, this would be the beta coefficients and the y-intercept. Since we used a decision trees model, this is the final averaged tree that we would use to send the features into to find our way down the branches until we get to a predicted level of charges. So this model ends up being stored over here in our assets. Now it's not stored there yet because we haven't deployed this yet, but it will be in just a moment. Now there are a few other changes we want to make as well. In particular, this web service input, by putting this here, when we deploy, a web service gets automatically generated, and the way it determines what data is needed for the web service is by going to where the web service input connects and then back up the chain to where the data set comes from, and it examines all of the features in that data set, and then it will require them in the web service. Well, the problem with that is, you may remember, that the original data set has two features in it that we don't want. In particular, we eliminated sex from the model because it wasn't a significant indicator of insurance charges. Also, we don't want to ask them for charges anymore. We've trained a model based on charges, and we're going to use this web service to predict people coming into our business that haven't been customers before, and we don't know how much they're going to cost. That's what we're trying to predict. So we want to adjust this web service so that it doesn't request charges or sex. Let's close that out. And the way we'll do that is I'm going to take this select columns and I'm going to move it up to the top here. Let's move apply math operation down, move edit metadata down, and I'm going to pull, I'm going to delete this connection and pull insurance directly into select columns. Oh, but I got to delete this one first. There we go. I'm going to move this. I'm going to leave web service input connected down here into edit metadata, delete the output of select columns and connect it also to metadata. And what this does is we're going to use this then to say remove sex, which is already out of here, but we're going to edit this to also remove ln charges, which will no longer exist or be relevant. And by the web service connecting down here, it will look back up this pipeline, and it will see that only age, BMI, children, smoker, and region are coming out of this data set. And therefore, when the web service gets created, that's all that will be required by the web service. Edit metadata, do we want to keep this? Yes, because we want them to be able to send in a number of children and have it be cast into a group value. Apply math operation? No, we don't need it. Delete that, because since we're no longer requiring the label, there's no need to cast or to convert the label into the natural log. So I can delete that out of there. All right. One final adjustment I want to make. Data will come in here. It'll get cast into, the children will be cast there. It'll come down here. It'll get a scored predicted value, and it will send everything out to the web service, including the original data and the scored label. Let me show you what I mean. I'm going to submit this. You don't, if you want, hold tight on yours. Don't waste the time. Just watch me do this, because I'm going to make an adjustment afterward. So let me run this as it is and pause. All right, finalizing now. Take a look at my run overview. Not too bad. I was able to recycle these from previously. Usually finalizing only takes a couple seconds. Completed. Okay. So I'm going to right click on score model and show you what we're getting back. It's giving us, as you can see, all of the original features and the scored predicted label. Now remember that because we trained this model using a natural log of charges, that's the format that the data is coming back in. So when we call this web service and get back a predicted value, well, on the programming side, we're simply going to need to remember to take the exponent of this value to convert it back into dollars and cents, into its original range. Anyway, but the problem is I want to keep my web service as trimmed and quick as possible. I don't want it to send each of these fields back to me, since I already know what those are and I sent them in the first place. So all I'm going to do is add another select columns. I'll copy paste this one, bring it down here, connect score model into select columns, delete that, and then connect this to the output. And then I'm going to adjust these settings in here so that only scored labels are returned. I don't want any of these. Scored labels, save. And now you can go ahead and submit yours, and I'll submit mine. We have to run this pipeline once before we can finally deploy it. So I'll let that run. Okay, with the inference pipeline now run completely successfully, go ahead and click deploy. And let's give it a name, insurance endpoint. Only certain characters are allowed and no uppercase on these names. It'll tell you, for example, if you've done something wrong. There we go, can't have uppercase. Anyway, we create that, and now we got to pick our container type. So Kubernetes is their more scalable production type deployment. You can use Azure Container Instance as well in production, but this one is their, I guess, more powerful engine. The only problem is that it requires an inference cluster, and we would create that over here in the compute options, but we didn't create one before, and we're not looking for a big production app. We just want to test this out. So we're going to choose a container instance. Now, this also allows us, though, the advantage of a container instance is we can use a SSL and our own with our own domain name. We're not going to get into that, though. It'll generate a key for us to use just to make sure that we're, only using allowing authorized calls to the web service, but we'll skip SSL for now. It doesn't hurt if you're not familiar with this to watch a tutorial on YouTube or something like that, and it's not hard to get these PEM files and add them and all that. But anyway, we'll leave it for now. Let's go ahead and click deploy. And once we deploy, this model gets registered here under our assets. So if you come over here now, you'll see a new asset or model showing, and this is required to deploy an endpoint. So click down here now on endpoints, and this has also been created. It's not ready yet. We're going to have to give it a few minutes, but click on it, and you'll see its deployment state is transitioning. This endpoint will be the actual URL that we need to call to use this web service. When it's ready, it'll give us that URL here. But for now, transitioning mode, click on this. I think it'll go from transitioning to unhealthy and then to healthy. If there are other issues, then you might get one of these, but I haven't had those issues yet. So I'm just going to pause this for now, and we'll wait till this changes to healthy. You might also try refreshing. I've noticed sometimes it doesn't refresh right here. Okay, I now have a healthy deployment. We're going to test this out using a program called Postman. If you're not familiar with Postman, you can go and download it for free. Just go to postman.com and you can sign up for an account. Let's see, I'm already signed in, so it's not showing me the same thing you'll see. But if you explore this, there you go, download desktop app. I'm going to use that one right now. So open this up, Postman. Postman is a useful way to test endpoints also if you have no coding experience, but it can also facilitate writing code very easily, which I'll show you here in a bit. All right, beautiful. So because I've used this before, it goes straight to my workspace. You might need to create a new workspace, a new collection. This is just a collection of, here's my collections right here, of various types of APIs that I test and call. So I'm going to add one here to my in-class stuff collection and create a new one. And I have various types of HTTP requests that I can make here. This is where my URL goes from my, from my REST endpoint. I'm going to paste that in there. I'm not going to do a get, I'm going to do a post. Although I am getting information back, I've got to send it data. I have to send it the data for a particular case that I want predicted. So parameters, these are things that would go up in the query string right here. We don't have any required parameters, so that's empty. Authorization, I didn't enable any authorization for this, so that's not relevant right now. Headers is relevant. So these are the default ones that come from Postman. Yours might be hidden. I'm going to add a couple more down here. Content type, enter, application JSON, we're going to send it in a JSON format. And then there also needs to be a key. Oops, I always forget to hit enter. Authorization. And the key is bearer. And this is the format for, oh, I forget which one it's called. OAuth 2, I can't remember. Bearer space, and then come back here, and we need to find our keys, which will be, oh yeah, come here to consume, or it might be in test. Let's try them both. Nope, consume. Oops. Here we go. Here's the endpoint again. Here's our primary key. I'm going to copy that, paste it back here after bearer space, and then body, I have to send it. I have to send it data in JSON form for a particular case that I want predicted for. So to see what format that needs to be in, we're going to come down here to where they have consumption types and click on Python. I like that one. I think it's simplest. I guess they all have the same thing. Oh, no, actually not. Python's actually the format of the one that I want here. I'm going to grab this data equals, and it's a dictionary, which is basically a JSON object. I'm going to go all the way through the closing curly brace to that opening curly brace right there. Copy that. Come back here and paste it. And the only downside of this, I wonder if R does it any better. Nah. Only downside is it puts single quotes around these feature names. The endpoint wants it in double quotes. So minor annoyance, I just have to go through and change all these. Once you do that, you'll see all those red squiggly marks indicating errors go away. A couple others, we don't need these extra commas here at the end. We also don't need global parameters technically, so I'll take that off too, although that won't break it. Okay, so this is for a particular person who's 19, that BMI, children, smoker. Cool, I think that's it. Let's try submitting it. So hit send. And that was actually faster than I thought it would be. So here's where we get back our scored label. This person's predicted to cost 9.7488. Now remember, that's the natural log converted form. So I'm going to write code that will call this web service, get back a scored label, and then convert it. For example, let me open up a calculator here. Here's my calculator app. There we go. The actual value that's being predicted from this is, can I paste that? Yes. Where's my standard scientific? There's my E. Paste that value in again, E. Or, no, sorry, exponent. Clear. Where's my clear? Reset. No. Oh, C, there we go. Paste that in one more time, exponent. No, what am I doing wrong? Exponent. Oh, I have to actually go, I think, I have to go E raised to, let's see, that value. No. Let's see. Where's my raised to? This one right here. Okay. Clear that one last time. E raised to, that's what I wanted. That number right there. Equals, there we go. We predict this person will cost $17,134.13. So there's our actual predicted value. Another nice thing about Postman is this feature over here towards the top right code. This gives me various programming languages that I can export this call in. So most data scientists are going to be using Python. Request is probably the more common package to use. If I want to do some work in an IPy notebook file, I can copy this right here. And actually, I won't cover it in this video, but in our notebooks right here, well, maybe I will. Let's see how hard this would be to do real quick here. This is where we can create IPy notebook files. I'm going to call this endpoint test IPy notebook create. Okay, paste that code in here. All right, here's all the information. I think we're good. I don't see any problems. I'm just going to go ahead and hit Shift Enter, and there we go. There's our results back. So what I would do is actually print. I would first say let's convert this code right here into a JSON dictionary. So I'm going to call this JSON data equals JSON dot loads response dot text. And once it's in JSON format, I can print JSON data, and I can reference this like a dictionary. Results web service output 0. And then I've got a list, and that's in position 0. Then I've got scored labels. Don't worry if you're not following along with all this. Your instructor may not require you to know how to do any of this part right here. Scored labels, and I think that's it. Let's print that one out. There we go. Now I get straight to my actual predicted value. I can take this whole thing and I can raise it to, or sorry, I can, I'll use NumPy here, import NumPy, and I can, as NP, and I can say np.exp raised to that number. There we go. There's my predicted value of charges when I send this data in. And I can adjust this. All right, now they're 30. They're a bit older. Actually, let's go up a bit more. 42, up a bit more BMI, add kids. But let's change smoker to no. They live in the Southwest, and see what we get. Okay, look how much it goes down. Even though they're older, larger, have more kids, which all cost more money, by changing value of smoker to no, their predicted charges get way smaller. But very cool. We can now use this endpoint, and here's some sample code, and hand it to any developer we want who can go ahead and run with our deployed model.